Hello, welcome to the Desert Blockchain monthly session on Wednesday, May the 25th, 2016. It's about 5 minutes after 7 Arizona time, and we're in Gangplank Chandler, Arizona. My name is Jay Carpenter, and we've got a general discussion tonight on blockchain, crypto economics, and distributed ledgers and network architecture tonight. So, and we might talk a little bit about IPFS, and we've got some Raspberry Pis that are loaded with IPFS if we want to get into actually looking at the interplanetary file system. So thanks for tuning in. If you're not familiar with Desert Blockchain, our intention is to build community, to educate, and to innovate. So thanks for tuning in, and this will be about an hour and a half, and follow along. So, all right, gentlemen. Lennox, you want to introduce yourself?
Hello, my name is Lennox. I'm just interested in all the technology right now that's happening, blockchain, Ethereum, and like the future of it and how I could implement it into my future projects.
Cool. Rick?
My name is Rick. I'm genuinely interested in blockchain for applications.
Okay.
I haven't decided what yet. Too many options.
Okay, well, you mentioned something last time. Yeah.
A number of things.
Yeah. So, and you pointed out that Plan 9 was really, really interesting. So.
And there's a whole other world. That's something else. And the bad movie.
So,
James, my name is James Scooter, and I work here in IT.
Okay.
And I'm just here to absorb what's going on.
Cool.
Alan Chudnow, and I'm here to absorb as well. I'm interested in sort of building Internet of Things type status servers that are secure and have some of the nice properties of blockchain that's auditable, transparent.
Immutable and transparent and distributed.
Yes.
Okay. And so anybody, is it okay if we start off with the Internet of Things?
Sure.
Since that's something that you're interested in pursuing. Are you familiar with the IBM Samsung demo that was done a year ago at the Consumer Electronics Show?
No, I was there a year ago. No, I don't. So I was there, but I did not see the Internet of Things demo.
Okay. Are you familiar with that? Rick, are you familiar with it? Okay. And James?
No.
Is the Internet of Things of interest to you guys?
Yeah, kind of.
It is.
Yeah, they say it's a new thing. I'm not sure it's new as they think it is.
Okay. I think
Internet of Things is a term that's been around for a while, so it can't be very long.
what might be interesting. Sorry about that. What might be interesting is to go ahead and play this video. It's only about 9 minutes, but it shows what can be done with the blockchain and kind of the direction that Samsung and IBM were going into. So let me pull this up. So let's see. This is the article from CoinDesk. IBM reveals proof of concept for blockchain-powered Internet of Things. And I believe down here, where is it? So they used BitTorrent, Ethereum, and Telehash to demonstrate this. Let's see if we can.
Nickel cache?
Telehash.
Oh.
Oh, that's true. They still
Let me
like,
go back.
I was doing that really loud over everyone, so everyone hears how random I am. I used to write like 3-page long stories.
Here it is.
You're watching the protocol.tv.
So this is about 8 minutes.
Greetings from the IBM booth here at CES in Las Vegas. My name is Veena Pureshwaran and I work for the Institute for Business Value at IBM. We're a small think tank and we lead thought leadership studies around technology and business issues. So I had the privilege and the honor of leading a study on the Internet of Things late last year. And our vision in that study was to decentralize the Internet of Things to address problems of cost, scalability, longevity of the Internet of Things, as well as privacy and security issues. The output of that study is a proof of concept for the decentralization of the Internet of Things. And we're delighted to show you here a working functional demo in collaboration with Samsung to show 2 different sets of use cases demonstrating these ideas. So in order to achieve the functions that would be supported by a traditional centralized Internet of Things in a decentralized system, our architecture needed to support 3 foundational functions. The first of them is peer-to-peer messaging, secure, encrypted, trustless peer-to-peer messaging. And for this, we chose an open source protocol called Telehash to achieve that messaging. Then the second part is distributed file sharing for larger files, things like software firmware updates, analytics reports, things like that. For that, we chose BitTorrent, which is a much more mature, familiar protocol. But the third and actually most challenging and interesting part of this exercise is that in the absence of this centralized controller, we need some mechanism for device coordination. And we got our inspiration for that from Bitcoin, which is obviously the best example we have of a decentralized financial system. But we don't use the financial aspect of it itself. We use the underlying technology platform, which is the blockchain. And in order to achieve device communication and device coordination and those transactions on the blockchain, we selected the Ethereum protocol, which works very nicely to do the contracting between devices so that devices can create and set their own roles and responsibilities, permissions, and do some fairly complex bartering and negotiations between themselves, which devices almost completely autonomous. And in doing so, devices can become revenue generating opportunities in their own right.
This use case is about the autonomous washer. This is a prototype of a washing machine. We have inside this the software of the Adept architecture that Veena just explained to you. In the first use case, what we are going to show is that the washer is going to say that the detergent is going low. It goes and checks out if there is a smart contract in the background. And then it's going to go and place a request to the retailer that is being represented by a tablet over here. So you can see that the detergent low level is being detected here. It's gone and checked the smart contracts in the background and it's placing an order. Yeah, so the retailer has got this detergent reorder request with the device ID and the smart contract reference. So all this is being done on the blockchain. So now, having got this request, what's going to happen next is that there's going to be a digital payment, again over the blockchain. So this is a digital payment that has come in from the washing machine directly to the retailer. So all this is again using the contract terms, assuming that the contract terms is defining what's the payment for each detergent reorder. So what you're going to then see is that there's an order acknowledgement that is going back to the washing machine.
Most traditional Internet of Things architectures are very centralized and they are cloud-based, which means all interactions between the devices are through the cloud. our approach is by decentralizing the Internet of Things, most communication is peer, actually all communication is peer-to-peer, trustless and encrypted. And our transactions are built on the blockchain. So they are secure, private, and anonymous by design. So what this does is it shifts the power in the network from the center to the edge or to the devices themselves. And this is an idea that we describe as device democracy, which means that it's a very democratic process. The devices and the owners and users themselves control privacy and security.
Adcast is kind of the screen sharing marketplace for advertisement. Its concept is like this. If you have an NFT, it's a large format display, or it's a TV or any monitor, you can share this screen to anybody. First step is to select NFT screens. I'm gonna choose the 4 screens: Paradise Hotel, Aloha Cafe, Chipos Cafe, and Las Vegas Inn. The next step is to choose the advertisement file. I'm gonna choose this one. And now the request is received from the advertiser by using the peer-to-peer telemetry mechanism. Okay, look at the screen. The file is transferred, and then new AD file is played. And also, the digital coin is paid from advertiser to NFT owner. Digital payment is done with the Ethereum, that is the blockchain protocol.
The ideas for this demo were inspired by the paper Device Democracy, which you can find at ibm.biz/device democracy. And as you'll find, some of these ideas around decentralization of the Internet of Things are somewhat radical and maybe even to some extent futuristic. But in order to be credible in our in establishing the thought leadership here, we wanted to follow up the ideas introduced in the paper with a proof of concept, so that these radical ideas are not dismissed and we can actually demonstrate the credibility of these ideas and the feasibility of these ideas. And the idea here is that when you make these devices so autonomous in this decentralized Internet of Things, they become capable of transacting in marketplaces themselves. And this is something we described as a transformation of the Internet of Things into the economy of things.
The washer has detected that the failing part is in warranty. The next step, what it's going to do is to check whether who's the appropriate peer-rated service provider in the neighborhood. So once it does that, it's then going to go and place the service request to that service vendor. So what you can see here is that Washer has selected a service vendor, and it's then going to go and place the service request. The service vendor is going to get a request again from the Washer asking for a part replacement. Yeah, so you can see here, look at what's coming in here. So it's saying that there's a filter failing service request. There's a reference to the device ID itself, and then there's a reference to the contract. Now, what this retailer can do is that independently, he can verify that the warranty claim that is being cited by the washing machine is indeed valid. So that's what we're going to see here. The service vendor is going to go and check in the blockchain if the warranty status is correct and if whatever that the washer is claiming is indeed valid. Yeah. So the result is that the warranty is valid, and then it's going to go and create a service order, and it's going to be assigned to the service person. So once we do that here, you're going to see that there's an acknowledgement of service confirmation that is going back to the washing machine.
I'm Paul Brody from IBM. And I'm John Cohn from IBM. And I think we'd just like to say thanks for taking the time to watch this amazing demo. The technology that we've developed here is truly first of a kind, and it's been an amazing collaboration between IBM and Samsung.
And I love the fact that the blockchain is going to be unlocking the value in everyday things. And we look forward, watch this space.
Thanks very much.
Thanks. Follow us on Twitter to be the first to know about new videos from the protocol.tv.
So, what do you think about that?
Well, it's both amazing and silly. I mean, the idea of my washing machine calling up some repairman who will just show up at my house is so fraught with the possibility that, you know, someone will just show up and say, "Oh, your machine," almost like the cartoon for how the good guys sneak into the bad guy. thing by saying, "Oh, I'm here to fix your washing machine." Then I got to go check. So
Well,
they're
let's-
missing a couple steps.
Let's go ahead and fill in all the steps, because I just diagrammed that real quick. You get an error, you diagnose it, you decide whether it's a part or not. It's going to be a part. Very quickly, the first thing you're going to do is you're going to notify your owner, who at that point may choose not to participate in autonomous repair, but might say either check warranty or or get the part, basically, and they may do whatever they want to do. Washing machines up until recently have been fairly easy to fix. Depends on the part. Depends on the owner. But of course, if you want to go to the point where it starts bidding for a vendor, saying who's going to do this, if there's only one, which can happen even in Phoenix, all your complaints about do I trust my vendor are gone. You bought this particular brand, you bought a brand which is not serviced by more than one or maybe two vendors, you're kind of limited, that's the way it is. That doesn't change whether you call them and talk about it or not, but email's full. Email or text, whatever you want to do. Says we chose a vendor, or we have options, which vendor would you prefer? Would you like to call one and talk to them before they come out? You have to stay involved, you're right. There are some issues. Time to schedule, I think I'll be checking my calendar. Or my wife's calendar, or both of ours. And for all I know, when we set up our wash shop, we told her things like we work Monday through Friday and what our hours were. So it's not even thinking it's going to send a tech over at 9 o'clock in the morning, unless it has no other time. That's going to say, well, I got to negotiate this with you. There are a lot of steps, but it's all doable. So it really is all doable.
So then you have to consider, do I really want my washer to have all that ever increasing knowledge? Isn't that going to raise the price? I mean, aren't they going to have to go to some cloud service to get this anyway? So they have that service that's constantly learning new things.
I have a dryer at one of my apartments, which is too damn smart for itself, and it's just dumb as a blade of grass compared to this. But it's too smart for itself, and every once in a while it decides it's not good to run the heating element right now because it's too hot. But surprisingly, it's not too hot to cause an error, so I'm not going to tell anybody I turned off the heat. I'm just going to turn off the heat and let your clothes roll around cold. Thanks a lot. I really appreciate that. I think less or bad intelligence is worse than more in most cases. And we're getting washers to the point where they're trying to figure out what they're washing and how they can do better with it. You'd be more interested in the article about how washing machines and detergents today don't actually get your clothes clean anymore. That's a different problem entirely. Too much intelligence, mostly I think we need to stay in control of that intelligence by getting it to check in with us at every decision point. Do I want a vendor? Do I, you're sure about the diagnosis? There's no likely other thing. I'm hoping that the cloud that it went to at the manufacturer has already seen the many reports and has said, yeah, I know the error message says this, but actually we're getting all these calls for parts. So if you use our vendor, we'll ship you all the parts you need and they'll all be available just in case they chose the wrong one. You don't think car dealers already do this?
No, I mentioned, and now they probably do. It's probably part of the supply chain to think this through.
I was always surprised when I could go to AutoZone and buy a part for my son. May it rest in peace. Why? Because they usually had it. Why do they know to have brake pads for Saabs? They don't often anymore, by the way, because they track vehicle registrations. And they keep an eye on what's registered in the zip code, and they know there are too many Saabs in the zip code.
That supply chain really well.
Yes, they understand. They know what the difference is between having it on the shelf and having you go somewhere else. And you don't come back and say, I give in, I'll order it. You order it at the last place you stop at. Not
So I'd like
to AutoZone. It's a winner.
Contrast this model versus, I saw a video of a product called Viv.
Okay.
And Viv is done by the guys that did Siri.
Okay.
So the next generation Siri, this is pretty cool. It's basically you talk to your computer. Viv, you see it?
Yeah, I didn't see much of it, but I saw
I don't think they have much out, but it's basically like a Siri that sort of is much more easy to plug in new things. You can say, ask it a question, it will know, oh, you want to know the weather in San Francisco? Well, I know a bot that I can send that question to, and it will answer that app. And you've given me, well, if the weather is this, what clothing will I need? It sort of hooks all this stuff together in very clever ways. It's writing sort of a program on the fly.
Mm-hmm.
It's the technology they're using to hook together a bunch of bots, and the bots are on the cloud, so they're constantly learning and updating. And it's interface you talk to, understands natural language, you talk to it, is the mode they're suggesting is the best way. And we'll go and string together a bunch of apps, bots, whatever, together to sort of accomplish the command that you've given it to. So that, so I imagine that what you really want to do is you really want maybe not to have all the intelligence in the washing machine, to have the washing machine be able to say, here's an error code in the cloud, and it'll go somewhere where we can have the stuff updating without needing to put,
I expect
a 60 gigabyte drive in your washing machine, or 100, maybe that's small. You don't want a terabyte chip, right, that needs to know everything about everything. To do that, you want to keep your device small and cheap.
Is this supposed upon that the washing machine has access to some kind of currency like Ethereum or something like that it's going to pay the vendor with? And
Yeah, that's part of it.
It has access to your financials in some way. You either load it on there or you call it somewhere, and you have to refill that wallet or
Right.
that form.
And the currency is part of the program, because the program is using a certain amount of currency as it does processing. And if the device runs out of currency, then the program stops.
So your vendor is going to depend a lot upon people that are going to accept whatever type of currency it is. I mean, if it goes forward as Ethereum or whatever else they come up with, the vendor will have to accept that or exchange it, or do you want to do that? Or so the possibilities of, like, say, I have a dryer or whatever that I want this cool technology on, I can't do it aftermarket because, it's not possible to find anybody that works on it except for the vendors themselves that produce their own brand.
Well, there are exchanges. So there's something called Shapeshift that allows you to Ethereum to Bitcoin and all these other cryptocurrencies and whatever. And the direction is to weave in fiat money as well, so that there's this exchange of whatever. If I'm using Ether, which is the Ethereum cryptocurrency, and you're using British pounds, then we can negotiate that transfer. But there's a whole bunch of regulatory considerations and money exchange and laundering and know your customer and all that stuff. All that stuff is being sorted out. But basically, what I see in this video is a reverse of a vending machine model. Instead of people coming in and putting money into a machine, and the machine doles out something. This is the machine paying somebody else to provide goods and services to the machine.
It's not actually going to work like that, but it's close. It may initiate the transaction, but somebody in between is going to approve or disapprove.
Yeah.
Yeah. If your part doesn't happen to be under warranty, your washing machine's not going to order an $1,100 drive module on its own.
Well,
no, it's not. No, it's not. Or else it might do it twice.
Yeah. Well, I think you got to keep in mind that this is like a year and a half old, and it was basically just an initial.
We'll probably put this together in 3 months.
Yes, that's about right.
The concept's right. It's looking at the details. You're right. Control and notification are pretty important, because you don't need your washing machine charging items for you. You don't need that. It's not necessary. You can make that decision on the fly.
You just make a minor change, and instead of it sort of ordering the part itself, you can imagine it sends a message to your iPhone or your Android, whatever, it says, email, please, I'm in trouble. I need you. Yeah. If you do this for me, here's all the information, just mail this.
Exactly.
If you mail this to the vendor, then everything will take care of itself, and just type in the time you want the vendor to show up.
If I brought a different color pencil that put in all the checks that have to go in that I want to know about, my quick loop here would be full of little checks.
Yes.
It would be noisy. It would be annoying in a way. But the advantage is perhaps I don't have to go read the washing machine, figure out what the code is. I don't make a call or bring up a browser or push a button anywhere. It does start to happen. It's more of a push to me that says, I'm broken, I need this, go get it for me, or can I get this please?
Yeah.
And this is what it's gonna cost, and then something somewhere is gonna say,
Please press OK, or I'll take care of it. You know,
and if
that's
there are
kind of
options there, I can do this later, let's order the part after I
I see
talk
it
to
as-
whoever's buying it.
As a
works.
proof of concept, it's kind of cool, but I mean, you know, however much you're going to pay more for that particular dryer, I'm wondering if you could have a light that comes on the dryer that says it's broken and not get the same value out of it if you have to do that much checking and proving and going through and setting up accounts and all this kind of stuff. I mean, unless it does it all automated, which I think we've all talked about would be kind of nightmarish. It doesn't seem to be much easier than just having something that says I'm broken on the washing machine, and then you calling Maytag and having them come out and fix it.
Maybe the display throws a QR code for you. You can just quick grab and toss, and it goes and does, and simplifies the machine. But this is probably a very high-end washer. And whoever buys it's prepared not only to have a very special device, but they're prepared to put up with the extra expense to make sure it's as perfect as it can be. And that's okay. So if you want to spend $3,000 on a washer, that's the feature for it. If you only want to spend $1,000 on a washer, probably you're gonna have to put up with an orange or red light and a QR code on the screen that says send this, and you'll start the process much more conventionally because it ain't worth it.
We're thinking about this for washers, but in terms of like industrial applications, this would probably be really cool, where basically you have 100 machines you have to set up like this. So you want to take the thing, and the machine can say, here's some problems, and can tell you what you have to fix. I know that we talked to GE, and they're building an infrastructure like this, and they view this whole stuff as being like really important to lowering the cost of ownership of that, 3 billion watt generator that you just bought, and it'll diagnose itself, and send data back to the factory, so it's constantly running analytics about what might go wrong, and then alerting people to sort of make the most of your investment by keeping it up all the time.
Well, I think of 3 quick examples. Railroads are using microphones and RFID readers to listen to wheel bearings as they go by. When they hear a noisy one, they quick make a note of the tag that goes with it. Eventually, that car comes out of service quicker than it might have, so someone could go check it and say, "Yeah, bearing's bad." Because, as you know,
maintenance. It's the analytics to keep my products working.
Keep optimal, because with rails, probably their most difficult management problem is cars. Where's my darn cars? Can I make up this train? Can I do this? Breakdowns are the worst thing that can happen to them. Just as with airlines, airline maintenance isn't about safety, it's about efficiency. Planes that fall out of the sky don't carry passengers and can't pay the lease. I had paper mills as customers years ago. In 1979, the number 5 mill at Bucksport put microphones on all the calendar bearings. You want to listen to those. You catch them early enough, you repair them during scheduled downtime.
Did they write software listens? They write software listens?
They eventually had software listen to it. In the beginning, they had paper charts. And they'd go look at the charts, and a bad bearing was obvious. They would amplitude was enough. And a bad bearing
just amplitude.
It was
probably
obvious.
has some frequency components.
Well in advance of failure, it was obvious. So when Christmas shutdown came, you knew the calendar was going to stop. When it stops during production, it's not making newsprint. That's $1 million a minute that they're losing. They don't want to do that. The number 5 is a big machine. But during Christmas break, when they tear it down, they schedule that anyway. You get that work done. You don't let it go another year, the bearing would fail in April. Whoops. And I had another customer who made filaments for lamps. And their old filament winding machines were tough on themselves, and they were always tough. And they had to do quality control, because as one would wind a filament, it would eventually wear, and the tolerances would build, and it would stop making them to spec. They completely instrumented them, replaced the DC motors with servo motors, industrial computers, and they not only could verify what was wrong, when they took a picture of the filament and saw that it was not quite right, they would self-adjust the machine until it was beyond tolerance, but they'd stop it instead of making bad filaments and say, "Fix me, please." Great product. That was 1989.
How are they using the blockchain here other than just as a mechanism for?
How are they in the blockchain?
How they using it?
Yeah, how are they using this demo?
In
Contracts with the Ethereum.
Yeah,
the contracts with Ethereum. That's how the blockchain.
There's basically, in my view, there's only two blockchains right now. Blockchain, which was the first, and then the Ethereum blockchain. And the reason I say these are the only two is because they have live cryptocurrencies that are part of the whole system. There are other private blockchains that are out there, but they're
I'm aware
just,
of a company called Guard Time. It's a blockchain.
Okay. Well,
so there are others as well.
some of those use the Bitcoin or the Ethereum blockchains to add the monetary element to it. But there are private blockchains like multi-chain is one that we looked at here. But it's just sort of like drawing on the whiteboard. It's or it's like having a car that has no fuel in it. You know, you can look at it, you can play with it, and everything else, but to really drive it, you got to put the fuel in. And in my view, the blockchain is like somebody found the gas cap to the internet, and they opened it up and they started pouring fuel into the internet. That's really the difference in here. You take away the money, and it's all like kind of hypothetical. It's kind of like, I used to be a stockbroker, and people would say, well, I'm going to trade stocks on my little hypothetical ledger. And it ain't the same. It's, if you are not trading stocks until you actually have money on the line. That's the only time that you're really trading stocks. So,
I thought the best time to sell stocks was when you had other people's money on.
well, that's
But maybe that's
a different deal. But so I think we could talk about the Internet of Things and your use cases in like military constructs, because there's a lot of attention that's going into that. James, I don't know about your business or what your interest is, but certainly, Rick, you're in the financial services, and there's a financial component to this. Lennox, you're interested in entertainment, the part where they're talking about playing the advertisements, that you can substitute out, any kind of entertainment platform, any kind of mixed media, rich media, and that applies. But before we get into all that, I'd like to show you guys something that's a little more contemporary, something called Slockit.
Sure.
Are you guys familiar with Slockit?
Yeah.
You are?
I don't know.
So let's take a look at Slockit, and then we can have a little continue the discussion. Oops. Okay. So this is Slockit. 2 days ago, 12 videos. I should probably just go to their website.
That's at the CES in 2015.
That was, January 2015. So we'll just kind of watch their brief.
So what is the problem we are trying to solve? So most of you have a lot of property. How could you rent, sell, or share them easily?
This is 3 minutes, 30 seconds.
Hi, my name is Christoph. And I'm Stefan. And I'm Simon. And we're here in London at the first IoT plus blockchain hackathon to present Slockit.
Slockit is the first physical implementation of blockchain technology, and we think it's going to revolutionize the emerging sharing economy. But let us show you how it works.
Slockit makes smart contracts useful by making them enforceable. A simple example is a humble lock, or slog. A slog can be used with an Ethereum contract to open anything. For example, this slog-powered door can provide access to an office or rental apartment. These devices are coordinated by our first product, the Ethereum computer. Slockit is generating a wide range of technologies that can be embedded in any kind of smart objects. Individuals and corporations will be able to rent out bikes, issue insurance, and receive payment in one single step without being at the mercy of hackers or centralized payment providers. Airbnb owners with Slockit-enabled electronic blocks will be able to accept reservations via the blockchains peer-to-peer without a middleman. And Slockit-enabled digital padlocks make it possible to rent or sell anything secured by a lock. In each of these cases, these transactions will benefit from the transparency, auditability, and security properties brought on by the blockchain.
There's more. Slockit is also a platform for developers.
Because it works with Raspberry Pis, Beaglebird, and even with a tiny Intel Edison, any developer can build applications on Slockit.
We're building the world's first DAO, or Decentralized Autonomous Organization. Think of it as a company operating under a set of immutable rules controlled by the blockchain, so that even if the company was to go under, the service would still continue to operate.
To establish itself, the DAO will pre-sell a token. This token makes you a member of the DAO, giving you the ability to vote on important business decisions and receive a reward. This reward is created by the slots, when they are sold or when they are used. And because all of these rules are written in the blockchain, Slockit will operate completely autonomously on the highest level of transparency.
Slockit is a system for, in principle, opening blocks via the blockchain. But the vision is somewhat more comprehensive than that. I think we can understand it as being a project that seeks to connect the blockchain to the physical world in a very general sense. It's one of the things that really got me geared up to seeing, wow, you know, this is something that really could change the world.
Thank you for your interest in Slockit. It is very important for us to get your feedback and help shape the future of our products. So please visit our website on slock.it and let us know what you would like to rent, sell, or share.
So, and I in no way endorse or recommend Slockit, but this is where their DAO is at currently. And DAO stands for Decentralized Autonomous Organization. So their DAO, which is like a funding mechanism, it's like a blind venture capital pool, opened up on May 1st, and it's going to close in a couple days. And so far, they have what I would call indications of interest totaling $47.73 million for a decentralized autonomous organization that doesn't have, that basically has like 2 or 3 projects. So this is an incredibly revolutionary, I think it's got a whole bunch of issues associated with it, but if I assert,
So you go home and give them $5 and you can be part of the game.
right, and it's like an IPO basically for a venture capital fund, and just to kind of put another perspective, this is what Ethereum has done. So when you watch that first video, and that was in January of 2015. Let me see if I can make this bigger. So January of 2015, this is the total market cap for Ethereum. They had not issued any Ether. They had only done like a crowd sale and raised like $18.5 million. Well, on basically August 9th of 2015, well, August 1st, they had a market cap of 0. in 8 months, they had a market cap of $1.1 billion. So they went from 0 to 1.1 billion market cap in 8 months. And
people sold.
Well, and just now, well, they had a dip in their value, but on May 20th, they'd reached 1.187 billion. Now, of that, 147 million of that ether has been, I would say it's more like an indication of interest that those people holding that in ether want to participate in this DAO as sort of a venture capital fund for projects like Slockit and so forth. So the point of all that is that there's in addition to this decentralized, autonomous, smart contract platform and stuff, there's a whole new realm of capitalization, funding, all that stuff is on the table. So what do you guys think of that?
What does contract mean?
It's a program. It's a set of computer instructions that constitute this is what this thing is going to do. Does that make sense?
What is a Ethereum program?
Well, so the Ethereum.
Does that just mean it's some JavaScript? Is that how we do this?
Well, it's mostly written in something called Go, which is Golang, which is like JavaScript, only it's more structured.
Is it more functional language?
It's
probably has a lot of
functional.
constraints around the box that will fit
Right.
into Ethereum without breaking out of it.
Right. So Ethereum has multiple components in terms of the programming. C++, something that's like Python, Go or Golang, and I think they're slowly starting to lead in JavaScript, but those are the components that they mostly focus on. They've taken Python, they've created their own version, which they call Serpent, and they're building their own browser called Mist, and so they got a whole bunch of custom things. I personally find it rather complicated, and
It only took me 2 nights to get mining.
oh really?
Yeah. Mind you, I still can't calculate a million things because I haven't found a way to find my hash rate because the real trick with that is missing. I'm not surprised. I don't find that to be a deficiency. Every clever idea out there is barely documented and never presented holistically. You figure it out piece by piece. You try to, what do you do here, there? Oh, should we use that one? Should we use the other one from the beginning? I have 3 wallets because, forbid that I should be able to start up another list and not be told to register. You think you're registering your wallet? Think, wallet number 2. Congratulations.
But you successfully set up an ether mining rig.
Yes.
Have you gained any ether yet, or?
It does not enough horsepower to make any use of it. By the time I finish work, it's already gone by.
Yeah.
This is one of the problems with mining in general with most blockchain, where they require more complex mining as you go through and build all the available new blocks. You reach a point where it's possible that the last block will never be mined because it's just too much horsepower to do it. So if you don't
the
get
power
it early,
density more than the value.
yeah, basically. Now, perceived value, because right now in Bitcoin, for instance, if you're mining, you're trying to figure out how many hashes can I do, what will literally cost me electricity to run enough hashes to create a new block, and can I beat everybody to the next block, or what is going to happen there, blah. It's mining pools now, where people will take a lot of resources and roll them in a pool, joining the effort and sharing the Bitcoin when it's finally minted. This will happen to Ethereum too.
Yeah, and
I think they've already accommodated mining pools.
well, they
That's just, to me, that's not just technology. It's inevitable in the Bitcoin block mining concept. If you're thinking about doing an IoT blockchain, I think I might start experimenting with Ethereum in this on the test side and see how small a private chain I can make that I can mine the coins in advance. So I have a completed block and I'm now only doing transactions. And if you want to be part of this, you're going to have to join. So, because I've already done it out. I've got 2 garage doors and a gate in the front door. Where I'm going with this. Each one of them is probably going to have a wallet. They're all going to talk to each other. We're all going to agree that we can do certain things and can't do certain things. I can use an Ethereum contract that says, if you ask the right question, I'll open the garage door for you. Or if I answer the right
Or
question,
it can go out
I'll
to
open the gate.
you can go out to some sort of oracle that you trust, and in the event that something happening via that oracle, then it'll trigger some sort of instruction.
Critical is, I know all my devices because they have wallets that I'll accept. I probably made the wallets for them, or whatever. There's ways to deal with that. They can all be, once you get going with an Ethereum computer concept that can do the work that Slock wants to do, now you're talking about simplified controllers that'll come with a pre-configured wallet, and you'll accept that wallet. However you do that, mind you. It's awkward right now, but that can be fixed. There's a QR code. So that you can just slam the wallet into your chain. Boom. Okay, I'll accept that. Most importantly, I just need to be sure, and I think I can. My chain will not accept an unauthorized wallet. It'll ask, and I'll say, no, I don't recognize that. And in fact, it'll only ask for a very short period of time, because when I'm adding a switch for the back door, I don't expect to take a day to answer the request to admit that device to my chain. That's going to happen in a moment. Those requests live for 15 minutes. And then the system says, oh, well, I didn't get an answer from you. You'll have to try that one again. So if somebody out of the blue figured out how to give my front door lock a new wallet ID, new key, and I would see my front door lock has changed its wallet key, oh no. I'll have to use another form of access when I get home, but my front door cannot be trusted anymore because it's got a wallet I don't recognize. Okay, I'm satisfying some security questions with a reasonably secure method. What I've seen of the Internet of Things, security isn't an afterthought. It's just where the real world, it can't be sophisticated enough yet to actually work. People are ripping off every bank. You think they're not going to rip off my thermostat?
Yeah, well, and that's already happened.
It's already happened. There's a few thermostats. Actually, there's a few IoT brands I'm not interested in anymore. Their security has been compromised. They got it wrong once. I'll give it a second chance.
Right. And there's been problems with Nest, and they don't even have a cryptocurrency component.
Well, they don't have adequate security.
Yeah.
End of discussion.
Right.
Whoops. There it is.
Yeah.
I mean, mind you, your thermostat's not the most deadly thing, but you wanted Nest to be my front door lock, you'll have to do a lot better.
Yeah.
And I'm not looking for Slage or Kwikset to fix this either. They're not in that security business shit. They'll have to learn it. They might. That's cool. I can go for that.
The difference here, Rick, and correct me if I'm wrong, because I'm not steeped in Ethereum and so forth, but the difference here is you have this monetary component as part of the security fabric. So
when you say monetary, we remember cryptocurrency is data that we assign other value to. Well, the value I assign to my cryptocurrency, whatever you want to call it, within my private chain, that currency, there are actually uses for currency in my system. There are possibilities.
Fiat currency or cryptocurrency,
Crypto.
or both?
Crypto, because you're just talking multi-currency solutions there. Something's been in my mind all day because I'm going crazy with multi-currency dynamics, but we digress. It's, currency exchanges can be dealt with. I consider that a trivial problem. The difference is that people think fiat is real and crypto is not.
Currency in your unlock my door.
Well, for instance, there might be things I don't want to run any more often than they ought to, so I would prefer that they not spend my currency any more than so much per day, like the pool motor, as an example. So if somebody wants to turn the pool motor on in the afternoon, I might say you can't because of my electricity pricing program in the afternoon. It costs you too much to turn the pool motor on. You ain't gonna do it. Sorry. And you'll have to beg someone to override that.
Well, that sure seems complicated.
It is
They just
complicated.
say,
It is. You're right,
they
it
just
is.
say, don't run more than a couple hours a day without letting me know.
Well,
Well, you
right now
gotta-
I have a timer on it. Timer, so I have to keep resetting it every once in a while.
Oh.
Also, here it's on astronomical time, so it doesn't know the seasons.
You got to keep
Yeah,
in
this how
mind.
deep do you want to go? Most of this for me is literally fun to think of what is possible and could be done. But there are people for whom this could actually be of value.
Oh yeah,
And both of them might not buy it.
and
I know.
and the thing you got to keep in mind is this is still in the very early experimental, innovative stage. So, you know, I went through the introduction of the internet. And, you know, it used to be that if I wanted to talk to Rick, I'd pick up the phone and I'd call him. And then this thing called email came along and it was like, oh, well, why do I want to, you know, send him an email? I'll just pick up the phone and call him.
And eventually email got there.
Right. And eventually email became the asynchronous nature of email surpassed the synchronous nature of a phone call. And it's rare now that we make phone calls. But at the time of the introduction, it was like, well, this internet thing, I can do everything else.
Oh yeah,
The old
yeah,
way.
I've been there.
But the key, it's not so much about, you know, a lot of the things we've been talking about are sort of like database functionality or regular programming functionality. And the part that I'm really getting present to is this currency model or currency component starts to put a new level of skin in the game, in the whole system. So that part of your security is building like this game theory that makes it too expensive to hack in certain ways. That's the whole
that's the whole way crypto works, right?
Right.
If you had infinite time and resources, if you had sufficient resources, you could build a computer fast enough to hack almost any code, except maybe a one-time path, right? If it's algorithmic, it can be hacked. It's just a question of that the expense of building that computer isn't worth the value.
In the real world, the equation is, can I find out what that information is before it's not useful to me anymore?
That's exactly
At
what
the
I'm saying.
highest level, at the
Right.
state, at the sovereign level of dealing with encryption, the NSA, for instance, can they decrypt messages quickly enough to be able to use them? Because if you set a set of messages aside and say, decrypt these, and it only takes like 45 days, well, yeah, you decrypt them, you find out, yeah, that was the bomb that went off 3 months ago.
Sometimes, and sometimes that's the case.
Sometimes that's
45 days is a good deal.
It might be a good deal. You're absolutely right. And for instance, in Bitcoin, most of the significant threats against Bitcoin have literally taken too long to unfold. The system has foiled them because you couldn't fool the blockchain well enough, quickly enough to make it stick and get away with it.
Right.
That's unfortunate. They've learned you don't go after the blockchain, you go after the wallets. Because the wallet's persistent and you have all the time in the world to crack a wallet. And once you do, you empty it out and that's the end of it. You're all done.
And the disasters that you've heard about around Bitcoin have been because people went back to a centralized model that was breached. It wasn't really a flaw in the overall architecture of Bitcoin. It was the human part of Bitcoin that's yet to be solved in terms of how do you keep your private keys.
Your wallet? How are we keeping our private keys private?
That's been a problem since the beginning of the internet.
Yeah.
Congratulations, you've touched upon it. That's
Yeah.
why setting your private keys on your server is a pain in the butt.
Yeah.
It's supposed to be. It's hard for you. It's really hard for an attacker. So you really have to pay attention to what you're doing, and most of the good systems out there force you to jump through the necessary hoops. You don't just drop it in your shadow.private key file for everyone to peruse and say, oh, that's cool. I know what that is. Great, thanks.
Well, I think that's the opportunity for financial institutions is to usher in a workable set of human interfaces and human conditions so that you can manage these private keys. And you do that with something called multi-signature, multi-factor authentication available.
So when I have my washing
You
machine,
end up with EMV.
The what?
You end up with EMV. A chip.
That chip?
Hard to fake the chip. You can fool the chip, but you can't fake the chip very easily. And once you faked it, actually, all hell breaks loose, because if you can fool or fake the chip and you run a transaction, when mine goes bad, I know something's gone wrong. I'm now triggered to the breach, and I can start fixing it quickly. But when they clone your card with a stripe on the back, if you're diligent, if you're observant, if you're watching, or if anybody is watching, you might catch that. But for a lot of people, it doesn't happen that quickly. I can tell you stories, I know.
So
this is where your credit card is going. This is a debit card. There's EMV in it. Yeah, Euro, MasterCard, Visa chip. You're getting chip cards. You'll have to dip instead of swipe and things like that. That solves a multitude of problems. And
well, that's
blockchain
security by something you have and something you know.
Actually, this is cryptography. This exchanges keys that change every time it gets used.
But that's a physical thing that you have. It's like a key lock, basically.
Well, and this point, it will always be a physical thing you have. Even if it's your Apple Pay, it's actually code in your phone and keys that are being exchanged that allow everyone to agree that it's legitimate, it's an acceptable transaction.
As long as no one takes your phone and they haven't been watching over your shoulder.
Well, if they figure out how to undo it, blah, blah, yeah, of course. If they steal my card, I'm not going to keep them from dipping it and taking advantage of it. And since we haven't implemented PINs yet, they can just sign for it, and signatures is such a waste of time, but we're stuck with them. The blockchain is what keeps that information not merely secure, but, correct me if I'm wrong, verifiable, because it's very public. Everybody sees all the transactions. And if something doesn't look right, it can be stopped.
So that's the advantage in my app, is that it's, I think, auditable might be the good word. So I can do forensics on it to say, something really goofy went wrong. Let me go back through and that's where it happened.
And this is
because I have this whole set of blocks, which is pretty much really immutable. Or if someone's messing with it, I can detect where it's been messed with.
This has happened in Bitcoin, where people have tried to double spend by flooding the network with bogus transactions and trying to get more than one to go through for a specific transaction, for a specific Bitcoin, a fraction of Bitcoin. They've tried to do that. That's been squashed pretty well. The protocol works efficiently.
Question about that idea. So, with Bitcoin, as I understand it, when you make a transaction, there's a certain period of time in which it has to be verified. But people go ahead with transactions in the interim, and then you're not really sure if that actual money or Bitcoin will be transferred to you, or how does that work?
Yeah, there's a 10-minute time period for validating the block, and we've got this competing network of nodes or miners that are all racing to validate the block and win a payment of Bitcoin. And it happens like every 10 minutes theoretically. It's my understanding it's taking longer now.
Yes.
But the idea is you've got all these competing entities that are racing to all validate the accuracy of the transactions.
And you're wondering why they're racing each other to validate transactions. It's because now Bitcoin has gotten to the point where it's popular and busy enough that you actually have to offer a transaction fee for those who will validate your transaction successfully for you.
Yeah.
It's a micro fraction, it's a teeny tiniest little slice, but nonetheless, if you do 1 million transactions a day for 1 millionth of a Bitcoin, that's a measure. Millions of Bitcoins are usable amounts now.
So you've got this market mechanism at play that starts to determine priority of processing. It starts to regulate, do you still have enough fuel left to do any processing at all? And it starts to build these like game theory incentives that come into play in terms of not only the validity of the whole thing, but also the security of it. Because if somebody gets enough power to do a certain attack, then they can breach the security of the whole ecosystem. And that's a big concern.
That's been tried.
It's been tried.
It's so far failed because the community recognized that and overcame it.
Yes.
Technically, if you have 51% of the computing power in the Bitcoin blockchain, you could conceivably force transactions that aren't genuine, aren't acceptable. And by overwhelming everybody else with approvals, you could continue to do this. There are a multitude of solutions to that, including people who are actually analyzing the blockchain. They see where the error occurred, and they have forked and said, we don't trust the blockchain from here on. We don't trust it. We're starting back here, and we're continuing our work on this as it was back here. You, by the way, this means that all your transactions you've been submitting right along here, those aren't going to be recognized by us. That's important because the us are trusted processors. And the people that you don't know that are continuing on with this manipulated blockchain, one day may find out nobody's submitting transactions to them anymore. Their chain got stale because nobody trusts them. And by the way, that day is usually minutes. And when that happens, this blockchain, the fork over here by the trusted processors, survived so that everyone is doing business with this. This becomes the mainstream. This one simply dies.
They were saying that Ethereum had like Courier like that. I didn't know they did it for blockchain also.
Blockchain, surprisingly, most of the community processors figured this out shortly after the first really minimal attempt at it that was not very successful. And they started work on this quietly and privately with each other to figure out a way that they could, as a federation, bring this to the attention of the system in a way that people could choose which way they go, basically.
So an interesting thing in markets right now is that basically they're playing a game of time. Whereas if I know what you're going to bid, then I can go and buy it faster than you and then up the price. And so it seems like this 10-minute cycle in BitChain is incredibly vulnerable to those sorts of things.
What do you think? Well, do you think that arbitrage is an issue? Because that's what you're talking about with high-speed trading. Yes, high-speed arbitrage.
Yeah.
I not only can beat you to the stock you want,
wouldn't be
cheaper
direct,
than you wanted to buy, but I can beat you so badly that I can sell it to you for a penny more than I bought it 1,000 times a second.
Yeah.
Times 60, times 24, times 365.
It all
It doesn't take. It doesn't seem to take much. Times one stock. Do it for the Dow.
There are two main methods to arrive at consensus. There's actually more. But
I mean, it might not really work that way because the transaction's sort of after all the bidding is done. So to speak, that's what I'm logging into the blockchain. But the fact that you
I'm being intentionally mean here. High-speed arbitrage is a different process. Very different. But some of the concepts do apply. You know, in that speed can be a problem in the Bitcoin blockchain.
Yeah. If I was going to sell you, or if I was going to buy your car, Bitcoin, we would want to sit at a table for at least 10 minutes before, you know, you hand over the title and I hand over the Bitcoin private key, because we would want that transaction validated. We would actually want to sit there longer because you want it to.
Yes, in the database world, you would want a complete ACID transaction, right? You want everything to close, be verified.
Yeah, you'd want it all validated on the blockchain before, you know, you give me the keys to drive your car off and I'm, you know, satisfied that, and you're satisfied that you're paid.
That's no worse than going to your credit union and either getting a cashier's check or negotiating a cashier's check.
Right.
Probably quicker than that. That's also why Bitcoin vending machines don't look like a winner.
The difference is that if I, you know, drive off in your car or you drive off in my car or whatever, there's no customer service to call. If something happened and we want to reverse the transaction, sorry, it's done. And, you know, it's...
Yeah, but if I deposit my check from work, they're going to say, well, you can use half of this, but you're going to have to wait 2 days until we verify the funds. And then if there is a problem, they're going to charge me money and tell me, well, go see whoever gave you that check.
So let's assume you made a legal purchase, right? There are legal means to deal with that, which are outside the blockchain. Just like if you bought a car and it crashes in a day, Visa isn't your first stop, right? Your first stop is some other person like that company that you bought it from, or a lawyer, and then you might go to Visa to say, hey, they sold me this, you know, downgrade this merchant so it doesn't sell any other things.
But if I go to Amazon or PayPal, PayPal or Amazon will take my side and charge me back and say, hey, you know, yes, he wasn't satisfied, so we're taking our money back.
And you don't have that here. You've got, you've done the transaction, it's done. And but part of what there is to keep in mind in terms of this validation and this whole, you know, proof of work, and the other method is proof of stake, where people want to move to.
What does proof of work mean?
Proof of work means that all these miners that are out there that are validating the transactions that go into the blockchain, they are expending computing power, and they are solving a problem that takes computing power, which takes electricity, and whoever solves the puzzle first, the solving of that puzzle has communicated to everybody that node, that winner of the lottery, if you will, has expended an adequate amount of work or an adequate amount of electricity. You're basically exchanging electricity for Bitcoin. But you're in a race with everybody else that's trying to expend
the number before everyone else does.
Exactly.
So what if you had quantum computing?
Well, that's a good question, because IBM's just rolled out a cloud quantum computing service, supposedly, and the narrative that I hear now is, well, when there's quantum computing, then there'll be quantum cryptography. And the cryptography will keep up with the computing power. But there's a lot of people that are concerned because quantum computing theoretically could breach the...
There are some systems where quantum computing is appropriate, and there's some algorithms where no one has a quantum solution yet. So it's just like other cryptography. No one knows how to break this. So I know that guard time, they claim to have use a type of cryptography in their hash which doesn't have a known quantum solution.
So let's back up just a little bit and look at, okay, why is this fundamentally interesting compared to the methods that are out there outside of the blockchain? Because databases can do a lot of this, programming, a lot of this stuff can be done the conventional way. Here's some of the fundamental compelling points for, let's say, your application, if I understand it correctly.
It's just distributed status.
Well, it's distributed, which gives it a different level of viability or existence. But there's also game theory that comes into play, so that part of the community that I'm dealing with can be completely adversarial. So what would it look like if you're on a battlefield, let's say, and some of the people that are doing the verifying are actually your enemies?
Don't know. That's sort of what I want to prevent. Yeah. For what
it's what you want to investigate at this point. Is you've got this ability to reach consensus among people that don't trust each other, fundamentally. That's a big deal in my mind.
You could put it equally well that they have no good reason to trust each other.
They have no good reason to trust each other.
So what they trust in is the process.
They trust the process, exactly.
If you successfully mine the block and verified it all, then you look through the chain and you recognize that in the classic example that Bitcoin uses, Ann and Bob wanted to exchange Bitcoins. Ann's got enough Bitcoins, she submits a transaction, says, I want to give these Bitcoins to Bob. The system says, oh, yeah, actually you do own those Bitcoins, don't you? How remarkable. And not only do you own them, but we know where they came from to you. So we know remarkably that you received the Bitcoins from so-and-so quite a while ago who had them. And because you've had them for a while through many blocks, so we know that no one's challenged them, we're confident that they really are yours, high degree of confidence. You want to send them to Bob, and Bob's a legitimate member and can in fact receive Bitcoins. We know how to give them to him securely because he's used his private key to post. So we're going to do that. We'll literally solve the block by verifying it all. Say, great, these are now Bob's Bitcoins. And so when Bob goes to spend them, someone says, not only do we know you've got Bitcoins, we know where they came from. They came from Ann.
So that's dependent on having a secure wallet.
That's key. Well, having a secure wallet is key because if you lose control of your wallet, people start messing with it. Whoops. So they start issuing transactions that are either invalid, and this causes reputational problems. They just take them.
That's the real question, right? So breaking into the system essentially means stealing a wallet. So how can I protect against? That's the problem I'm protecting against.
You can have your private keys on some sort of container like this, which is a hardware device that that you can turn off so it becomes cold. Is that an actual wallet? No, this is just the keys to my car. Oh, okay. But the concept's the same.
That's probably sending a code to your car now.
Yeah.
No reason it couldn't be a private key.
Right.
But we don't care what the data is, how long it has to be, whatever. If it's sufficiently large and it can't be eavesdropped on, it could be anything. Since it can be eavesdropped, then it's going to do what my EMV chip does every time you use it. It negotiates a new key on its own, which will be accepted by your car because you both use the same method to generate new keys each time they're used. They know the methods, nobody else does. You'd be guessing at the billions of potential codes. Public would be the next one. Public-private. This is basic. This is PKI.
It's PKI
and
infrastructure.
By the way, this is why voting is important because you want to vote for people who are leaving encryption alone.
Yeah. But effectively,
I'm not sure who the heck that is.
Effectively, this is
what do you think's going to leave encryption alone? They're both both the main candidates.
It's a fundamental conflict between the legacy security paradigm that we're used to and what's available.
I mean, I heard Obama speak. He said, "I want you tech guys to come up with a solution."
For me, the problem here is between the state and the individual. Government that wants to be able to, when it wants to, take any information from you is going to want to have a back door. You as an individual know that if they have a back door, sooner or later somebody else will.
Yep.
I want something that can't be backdoored without my knowing it and being able to react to it.
And so I think that neither of your candidates is especially friendly with leaving it alone.
Neither.
Well,
only two.
The point
so it's not okay.
The point is that we're already using a similar construct today in this. So basically, if I leave this on the table, somebody has control of my car. If this gets out of my control,
until you reprogram the.
So that's what I like about the blockchain is that even if they steal your wallet and go back and audit the transaction, and say these things make sense. So I have this whole set of immutable exchanges. So I could write the auditor, and he could say, just monitor these three blockchains and tell me if something weird is going on, and if I can trust my auditors or keep several of them trustable. The majority of them trustable.
Without delving too far, your app is distributed statistics, basically. Is that right? Did I hear that?
Yeah,
right?
yeah. Status.
So for you, accuracy. What's the other word I'm looking for? Accuracy and verifiability are important.
Yes.
It's the quality and integrity of the data is crucial.
Yes.
Blockchains solve that problem with not only with their transparency, because you can't modify them without being exposed, but also with the genuine security that only those who can be part of the blockchain can even begin to try. So out of the blue, someone submits transactions for Bitcoins that don't exist. The blockchain very quickly figures it out. It's just miners say, I don't have any record of this coin. I don't know where this came from, and they won't authorize the transaction, and it doesn't even become part of the blockchain at that point. It gets ignored and forgotten.
Yeah, so those are all really good properties for this.
In your application, you're talking about a military environment, right? Possibly.
It's all the same.
Yeah.
So whether it's military or industrial, I want to exchange status, and there are hackers that want to break it.
Mm-hmm.
Hackers, in my situation, might be other governments, or in some other situation, there might be people that say, I can profit if I can make GE buy another jet engine here because of whatever reason. Or I can just mess with them for my competitive advantage.
In addition to this game theory that keeps the system honest, basically, there's also the fundamental construct behind the blockchain. Are you familiar with Git, which is a cryptographically connected and secured and hashed?
Is that GET?
GIT, or GitHub?
Oh yeah, GitHub. I'm quite familiar.
Okay.
Yeah, that's the GitHub.
So both GitHub are using a similar construct to the just called the Merkle DAG. ASIC.
Oh, I didn't know that. Okay. Yeah, I didn't know GitHub used Merkle tags. Yeah.
Well,
we talked about that yesterday.
Yeah.
I understand acyclical graphs.
So part of the interest and the attraction of this whole paradigm is that you have these forkable and trees that can go here and there, and then they can come back together, and there's consensus that this is what's supposed to be. But it's Git and GitHub basically are like community coding. So you've got this community construct that's working for a common objective.
Yeah, how does the fork work? Because that's a manual process. Right?
Fork where
in a blockchain. Fork a blockchain. What does that mean?
Generally speaking,
there's a human that says, I don't trust this. The indications are so honest. It could start from here and work forward.
It could be automated. There's no reason it couldn't be automated or programmed, but a blockchain, as we're thinking of it, a fork is a bad thing. Well, in GitHub, for instance, when you fork code out and you get to the point where it's too attractive, it wants to be merged back into the main code base again, that's a good thing because the community accepts it and says, yeah, this is better. We're getting better value. It's a beautiful thing.
Forking GitHub is completely different.
But in blockchain, fork is a bad thing because there should only be one blockchain. A fork can occur accidentally when systems can't keep up. And for some reason, a bunch of miners accidentally are going down a different road, not getting all the transactions that are being submitted to the blockchain. Those are awkward. That's a problem there. Re-merging those is a challenge. There are some miners who have successfully done this, I think. Those forks usually last minutes, and they realize, oh crap, that's come back. But then the worst thing that happens in a fork is that if the fork occurs, and this, for instance, is a good fork, which is functional, most of the chain is going with it, and the bad fork, like for instance, they had a network problem, and they get isolated, the bad fork dies on its own, and those of you who were hoping that you would be able to process those transactions, you quickly find out they're not being accepted by the majority.
So the majority happens most of the time is I have my chain here, I have my chain here because it's distributed.
One chain. One chain. When the chain forks, something bad happens.
So I have an instance of data here and an instance of data here, which are both part of the same chain.
Right. They were one.
But then for some reason, this one got out of sync. So now I have
correct me if I'm wrong.
Local instances of data.
Correct me if I'm wrong, but the key here is the blockchain is the stream of data. It's the one, it's the only. For Bitcoin, they have one specific blockchain that keeps getting mined, updated on a regular basis. It's a beautiful thing. If something bad happens, and many don't agree for some reason that all is accurate, they can diverge from the minority in a way that we call a fork,
Yeah.
where they're processing transactions that weren't processed by someone else, and if it's what is typically a defect or an error, only a small fraction is left out in the cold. And they realize quickly, not only are we not getting any transactions because none of them are going through in the way we want, but most importantly, they're going to have to roll back some stuff and give up and rejoin the chain and re-update because they've lost their way. They've fallen off. It's not easy to explain, except that first remember, unless it's done intentionally, it's an error, and it corrects itself when the fork that is an error realizes it's dying.
Yeah, there's different types of forks. There are different flavors of forks. There's hard forks, soft.
Even if it's one thing.
Yeah.
Distributed parts, what you're describing are getting out of sync, right?
But
That's
the goal is
one
to keep it in
reason.
sync. It could be out of sync because someone did something inappropriate. That's another way. If they're out of sync, that's what a fork generally.
The point is that it's because of the rules and the construct of the whole paradigm of the blockchain, it trues up. So over time, you've got this dispersed community, but it always trues up. Does that make sense?
Yeah.
And another way that I think about this whole thing is that it's kind of like our country. Our country is based upon the Constitution. So it's the fundamental rules of the blockchain and the fundamental rules of what the entire community's agreed upon by being part of the blockchain community. Those fundamental rules constitute the trust and the collaboration and the...
Yeah, it's a very interesting analogy. Yeah. So when some state passes a law that everyone else thinks is just crazy, right? Then eventually they'll go to the Supreme Court, and the Supreme Court will say, no, that's not so crazy. And they'll reset, or they'll say, no, you got it exactly right. Everyone else is wrong, and so we'll flip our operating system.
Well, you've got this, in a court, you have to show perhaps some cause of damage. You have to have standing at the very least. In the blockchain, if the blockchain forks because of a problem, then eventually the fork which has failed has to realize it's all alone. It has no standing. The majority has decided it's going to be this fork which is valid and accurate, and this little poor straggling fork here has to die because it's no longer valid or accurate. Nice try.
It's not exact, but you can see you've got this competing, somewhat adversarial construct that over time things start to true up.
We are seeing this in the Constitution now. We are seeing this in real life where in this case, the federal government has said, you have to do this. And at least 2 states have said, no, actually, I don't think we have to do this for a variety of reasons. We disagree. And we're not only are we not going to, we're actually going to try to use the court system to tell you, just stop telling us and other states to do this, because we don't believe you have the power or authority to do this under the Constitution. This is going to prove to be a great fight.
Yeah.
Fabulous, wonderful, and this is what courts are made for, to intermediate between various groups and individuals.
There's also competition among the states in terms of, if I get to a certain tax bracket, I start looking at Nevada as an attractive alternative to move to.
Should I look at New York or California?
That's right.
Florida's not a bad option, has its pluses and minuses.
But the point is, there's this kind of game theory going on that we've experienced for a long time. And you can expand it out.
Sure. I understand all that. So one of the differences, sometimes the minority is right at the Supreme Court, and it's going to be rare that the minority is right at the blockchain.
It's just a way to kind of make sense of this whole thing.
Well, the key in the blockchain is that consensus is important, because if you don't have consensus, you don't have a single chain anymore. It's scattered everywhere. Nobody knows who's true. Consensus is not just enforced. Consensus is so desirable that nobody wants to go without it.
Yeah, exactly.
And really, everyone. And again, proof of stake means I want the valid chain to continue. I want it valid because I
Take it as
need,
an I
need it to work.
I understand what you're saying.
I need,
So,
I need it to work.
the analogy's not perfect, but
It's not perfect, but it's just a way. It's another way to look at it. So we're kind of at our 8:30 mark. Was
this was awesome.
Was this what you wanted?
Yeah. I would like to see the demo too, but we're out of time. So
okay.
You should study Ethereum, and especially you should study.
I never heard of Ethereum until yesterday.
You want to study the private networks and the options there, because there are real possibilities in what you're talking about, building basically a private little blockchain that works the way you want it to guarantee the validity and accuracy of data.
I'm thinking of just calling up IBM and saying,
yeah,
team with them all the time.
IBM has a blockchain cloud service. Microsoft has a blockchain cloud service in their Azure.
Ethereum's open source, isn't it?
Ethereum is open source.
Okay, so all I just need is someone that actually knows how to program.
Well, maybe, Rick, would you be
quickly.
willing to bring your mining, your Ethereum mining?
Next time I'll have it running on a real machine that can keep that.
Okay, cool. It'd be awesome. I would love to see.
I don't know if I'll be able to get anything happening. By the way, Ethereum, Ether mining, just like Bitcoin mining, is very intensive. I'm not going to be making anything happen.
Yeah,
but when you create your own private network, you mine your own private currency, which, mind you, while it's not Ether and is not directly translatable, you use this along with contracts, which are literally software code that runs the way you want it every time. It can't be stopped once you start it, and that's the key to it. That's key. You can't change it because you don't have the right to do it. That's protected data. You're not allowed to. So when you write your own little contract that says, when this happens, I will blank, you will blank every damn time you go. When this happens, it will blank, and that'll be that. And everyone who participates, you're going to have to tolerate that. So when they do something that triggers your contract, boom, this is going to happen.
You can think of the cryptocurrency as kind of like rewards programs at a sandwich shop or a Starbucks or your frequent flyer miles.
Yes.
So when you get frequent flyer miles, that's actually money.
Well, it's a currency.
It's a currency.
But it has value.
But what Rick is alluding to is through the Ethereum blockchain, you can actually create your own Allen's cryptocurrency, Lennox's cryptocurrency.
We explored this in another group where you can use Ethereum and the concept of contracts to build a loyalty card program amongst local merchants that would operate completely independently. It would be all yours to run, and you could have them buy in as they wish. You can have them buy ethers and use those to buy your currency and there participate. You exchange value, you do things. Just if you have a reward card that gets you airline miles, those airline miles are fungible. That's real money.
Yeah.
That you know this when you go and you book a ticket with them and you actually go somewhere and they actually let you on the plane. You just took a $600 seat someplace. That's not just data someplace anymore. It's actual value.
So my Kana right now does not have any sort of monetary value. So I have to update my metaphors to account for that. Right? It's kind of like, it's give you status, and you don't have to give me anything. My job is to give you status. I do it for free.
But see, that's a centralized. That's a centralized authority construct, where you, as like the administrator, have the power to grant additional permissions or additional.
Yeah. So I actually think that's how it works. That there's some central authority that says, here you go, here's your keys, here's your keys, here's your keys, here's your keys.
The key in Bitcoin is there are two ways to gain admission to the Bitcoin community, the Bitcoin process. One way is to mine a Bitcoin.
Yeah.
Or participate in mining a Bitcoin.
Or
so you get credit or you buy them. Oh, absolutely.
So the metaphor I don't see how the metaphor of spending money works in the application I've described. And I think that the way that that all these distributed things get money is that Big Daddy hands out money and says, here's your Bitcoin, go have a good time, here's your Bitcoin, have a good time, here's your Bitcoin.
Well,
Something like that.
it's different than that.
But can your application be applied to like a pay for service sort of?
No, it could be applied to that, but that's not.
Lennox, are you an entertainer?
Yes.
So when people pay you, they pay you for your work.
Yes.
And their proof of work is dancing their little butts off.
Yeah.
It's not that much different from dollars if you're getting a paycheck. Now, if you're making your own paycheck, then it's your own effort. Your proof of work is people value it enough to give you currency for it. A wonderful thing. In Bitcoin, that proof of work can be the code to mine and the cycles and electricity spent, or you go right out and exchange another form of currency for it. The problem here is, just as you may be on the cusp of this now, we say currency, but what we meant to say was data.
No, I get that.
So you're being able to deal with status as information, which is important, needs to be accurate, needs to be verifiable.
Right, got it.
That's you've described currency in a different way. Your currency is data.
So
you'll get there. You will get there.
Okay.
I got there. You'll get there.
Yeah. Yeah. It takes a little while, but
I gotta work the metaphor so I
digest
can
this
explain it to people that are
James,
gonna be
what
close
did you
minded.
get out of this tonight? Was this what you expected? Is it?
I guess I got a few more answers and questions, so that's good.
Okay.
Got a few questions answered, a few more questions. So that's how learning works, I guess.
Okay.
I'm satisfied with coming in and listening for a little while. So yeah. Cool.
All right. Rick, was this valuable for you?
Oh, continuing to be, not just to refine the concepts and understand them better, but I'm monetizing all of this.
Mm-hmm.
Some of this is, how can I get on the ground floor of the next $1 billion opportunity? That's cool, but IBM, for instance, they're showing what they were doing, and I should get my notes out, but what they want to do, they want to capture that payment stream so that they become a value partner. I get that, but let me tell you, what a challenge that is, because everybody wants to own the payment stream. If you listen today, you found out that Visa's head seems to think that PayPal's not their friend. And they're going to crush them.
Yeah, really?
They're after them. Because they realize that PayPal is disintermediating them from customers. And they're doing this. PayPal wants to own the customer. Well, sorry, well, customer uses Visa to pay PayPal, go through the Visa network. Visa would wish that they would just go right through the Visa network. The fight is on. It will encompass everything. Apple Pay is smart because it doesn't care particularly which kind of card or bank or whatever. It just wants to intermediate the transactions and take a little nick off the top for having done so and keep people busy using their phone instead of that thing. Right? So Samsung Pay.
There's a lot of stuff on the table. Let's suffice it to say. So Lennox, what about you? How was anything you want to say to conclude, or?
Yeah, I just gotta go back and I feel like I have a lot to polish up on again.
Lot 6. He's a blogger. That's a music blogger, but he goes well beyond music in terms of his analysis of what's going on. I find him very interesting. Let me spell that.
Music is a very interesting market. Really, really interesting.
So it's LEFSET.
Seems like the blockchain could be quite a bit. I would like to be, to own a piece of music like that directly from an artist, and then it to be mine to distribute. But the artist being on his side, it would just be mine one piece of music that I can distribute. I can cast it and then send it to a million people.
So I don't think DRM is an issue.
Well, so
I think figuring out how to
first time's a freebie, second time you pay.
Streaming is the
there are people that are working on this already. So if you go to Ascribe,
I think there's a reason why Apple doesn't put DRM on anymore, why they got rid of it, because it didn't add any value for anyone.
So this is actually a service to secure artists' rights in digital art, basically, and other items.
Yeah, I've read about that.
This digital doesn't really matter what the media is.
Yeah.
That's digital is the distribution.
Yeah.
That's all.
I'm not saying that this is going to work or anything else. I'm just saying this, along with others, are working to create a new paradigm for rights and monetization and all that sort of
So let me tell you Bob's model, see if I can get it in a nutshell. He says, there is so much music out there that no one knows what to listen to. So they gravitate to things that the radio or their friends are listening to. So as a result, it creates a market where people that are popular are super popular, and everyone else, no, I don't have time to listen to that. I'm just going to listen to the things that are really, really popular. So as opposed to that we had where everything sort of levels out, where you can find your music easy, actually the reverse is happening. It's a super concentration of superstars are getting more and more of the pie, and everyone else is getting less and less and less. So unless you are a superstar, you're like way down here. So it's like
and there's
great concentration of wealth.
Two of my favorite artists going about this a different way. One is self-publishing her CD with a book and a presentation and everything, and it's basically a Kickstarter type campaign, basically crowdfunded using a different means. The other artist that really gets my attention travels the country doing house concerts. Now, not a lot of money at house concerts, but always sell CDs. Because you want to hear more of whatever it was, he'll treat you to a new song off the new CD. He's going through the alphabet. He's an M. He never thought he'd get past G. And he figured he'd eat all the F and G CDs. Nope. He's already got N in the works. He knows he's going to have to come up with an N, and it looks like O is going to be a go-to. And he books his travel ahead of time. He comes in, he hits houses here and there, anywhere from 10 to 40 people at a time. We pay. He gets fed well. He stays at a hotel. It's okay. It's cool. It's wonderful. It's a beautiful thing.
10 or 40 people is what he's pulling in.
That's as big a house as he wants to be in. Literally, my house, for instance.
Oh, when you say
kind of a
house
concert.
you're talking about like
living room concert.
not a public place. But
When he puts down the guitar to get the piano, we have to go over to the piano room because it's just and actually 10 people are already in the piano room. They get front seats.
So he's feeling it, right?
It'd be okay if we
was
was backyard.
30 years ago.
It have to be
Might
inside
have gotten a contract and they had a lot of distribution. Music is
my greatest source.
You'll look at this. You can decide whether you think it matches reality or not. But it'll be it's such a different point of view than everyone else I've heard.
I suck up all the free music off of Google Play I can. I have a lot of crap music, but I also have a lot of good music. I know, for instance, I see that artist and they're in my new free music. Oh, his stuff is so awful. It's free because it's awful. But someone here, I catch this artist and that band, they kicked it with that one single, and I actually bought one.
So I have Spotify for the family.
There you go. And
so
Spotify
Discover is amazing. Oh, I'm being able to listen to any song ever, whenever I want to, is worth for the family $25 a month.
But the problem is,
I'm going to sign off on this thing.
I just lost like 2 minutes.
All right. Thank you for tuning in, and join us next month on, I think it's June 30th. So last Wednesday of the month, 7 to 8:30 p.m.
That's exactly the point.
Arizona time.
You got a troll for
Thanks for your interest.
Well,